Selamat datang di Fakultas Matematika dan Ilmu Pengetahuan Alam Universitas Gadjah Mada. Fakultas MIPA UGM berdiri pada tanggal 19 September 1955, berlokasi di daerah istimewa Yogyakarta, tepatnya di Kabupaten Sleman. Fakultas MIPA merupakan salah satu fakultas terbesar di UGM, mempunyai 4 departemen, yaitu Departemen Fisika, Departemen Ilmu Komputer dan Elektronika, Departemen Kimia, dan Departemen Matematika, serta menyelenggarakan berbagai program studi yang meliputi jenjang sarjana, magister, dan doktor. Dalam mendukung kegiatan pembelajaran, Fakultas MIPA dilengkapi dengan 24 laboratorium, 22 ruang kelas, perpustakaan, co-working space, dan lebih dari 100 akses point yang tersebar di berbagai tempat di fakultas yang dapat diakses secara bebas bagi sivitas akademika UGM. Untuk sarana prasarana pendukung lainnya, Fakultas MIPA mempunyai masjid, lapangan olahraga terpadu, water fountain, kantin, dan tempat parkir yang cukup luas. Berikut informasi lebih lengkap tentang departemen yang ada di Fakultas MIPA UGM. Departemen Fisika menyelenggarakan 2 program studi sarjana, yaitu program studi fisika dan program studi geofisika. Prodi Fisika mendidik para mahasiswa untuk menjadi fisikawan yang terampil dalam memahami, mengamati, dan memprediksi gejala-gejala alam baik secara teori, eksperimental, maupun aplikatif. Prodi Geofisika mendidik para mahasiswa agar memiliki kemampuan untuk mengaplikasikan ilmu-ilmu dasar guna memahami ilmu kebumian, yaitu geologi, geodesi, geografi, dan geokimia dalam rangka memperoleh manfaat bagi kehidupan dan keselamatan manusia. Departemen Ilmu Komputer dan Elektronika menyelenggarakan 2 program studi sarjana, yaitu program studi Ilmu Komputer dan program studi Elektronika dan Instrumentasi. Departemen Ilmu Komputer dan Elektronika juga menyelenggarakan 2 kelas internasional atau International Undergraduate Program, yaitu IUP Ilmu Komputer dan IUP Elektronika dan Instrumentasi. Prodi Ilmu Komputer mendidik para mahasiswa agar memiliki kemampuan untuk membuat dan memperbaiki perangkat lunak sistem, melakukan dan mengawasi kegiatan instalasi dan pelayanan peralatan yang terkait dengan jaringan, membuat rancangan, mengaplikasikan, dan memonitor basis data dalam suatu organisasi, serta menerapkan prinsip-prinsip rekayasa perangkat lunak dalam mendesain, mengembangkan, menguji, dan mengevaluasi perangkat lunak. Prodi Elektronika dan Instrumentasi mendidik para mahasiswa agar menguasai sistem elektronika dan instrumentasi, pengukuran dengan instrumen elektronika, serta sistem dan pemrograman komputer. Departemen Kimia menyelenggarakan 1 program studi sarjana, yaitu program studi kimia. Departemen Kimia juga menyelenggarakan kelas internasional untuk program studi kimia. Prodi Kimia memberikan materi tentang sifat-sifat dasar materi dan perubahannya, beserta energi yang menyertai perubahan. Perubahan materi ditujukan untuk menghasilkan senyawa-senyawa yang bermanfaat bagi kehidupan manusia. Departemen Matematika menyelenggarakan 3 program studi sarjana, yaitu program studi matematika, program studi statistika, dan program studi ilmu aktuaria. Prodi Matematika mendidik para mahasiswa untuk adaptif serta mampu melanjutkan studi pada bidang matematika maupun bidang lain yang terkait dan mampu mengikuti perkembangan iptek, menguasai teknologi informasi, terampil dalam komputasi matematika, serta memiliki rasa tanggung jawab, kepercayaan diri, kematangan emosi, etika, dan kepribadian sebagai pembelajar sepanjang hayat. Prodi Statistika mendidik para mahasiswa agar menguasai ilmu dan terapan statistika, analisis dan pengolahan data, rancangan percobaan, basis data, komputasi, statistik dan stokastik, serta pengendalian kualitas statistik. Prodi Ilmu Aktuaria mendidik para mahasiswa agar memiliki keunggulan dalam hal penguasaan teori bidang aktuaria, prinsip siklus kerja aktuaria, dan memiliki kemampuan yang setara dengan aktuaris atau ASAI sesuai dengan standar PAI. Sebagian besar lulusan Fakultas MIPA memiliki karir di bidang akademik sebagai dosen di universitas negeri dan swasta, menjadi guru di pendidikan menengah, menjadi peneliti di berbagai lembaga penelitian, dan menjadi tenaga ahli di lembaga pemerintah atau perusahaan swasta nasional. Beberapa dari mereka menjadi konsultan atau berwirausaha berdasarkan sains teknologi. Informasi lebih lengkap tentang Fakultas MIPA dapat mengunjungi website kami di mipa.ugm.ac.id. Informasi pendaftaran bisa dilihat di website um.ugm.ac.id.
Huawei is a leading ICT company providing end-to-end service in more than 170 countries. For over 20 years, Huawei and Indonesia have worked together to achieve a connected, intelligent world. We are a family of more than 2,000 employees in Indonesia. We provide 5G solutions, securing 91 5G contracts with #1 standard contribution. We have 5G essential patents globally. We support the government with the Palapa Ring, connecting 7 regions and 440 cities and regencies. Our 5G use cases include mining, fishing, archaeology, agriculture, and more. In Indonesia, we achieved 5G trials with Telkomsel at Asian Games 2018 and disaster management trial with the Ministry of Communications and Informatics. We support the local community by investing in Indonesian ICT talents through capacity training for more than 15,000 ICT professionals, knowledge transfer to over 5,000 local students, including 100 students from 8 top universities through our Seeds for the Future program, and ICT competition as part of Huawei ICT Academy Global Network. We also have planned 100,000 Indonesia Digital Leaders program for the coming 5 years. We care for local communities and share with those in need. To support Indonesia fight the coronavirus outbreak in 2020, Huawei provided our technology for online education and video conferencing and AI diagnosis solutions for hospitals. We partner with Indonesia's major service providers and over 400 certified local subcontractors and participate in the Next Dev Summit with over 50 workshops on 5G, IoT and digital economy, 42 service partners, and over 500 vertical customers in the government, finance, energy, transportation, and ISP sectors. We also provided smart city solutions during the Asia-Africa Summit in 2015. We lead innovation in cloud technology and artificial intelligence. We aim to build a Huawei mobile service ecosystem with our local partners. In 20 years, Huawei and Indonesia has made breakthroughs in connectivity. Together, we can build a better connected Indonesia.
and Microsoft. And ladies and gentlemen, it is an honor for us to welcome each and every one of you with a very warm welcome speech from Dean of School of Computing, Telkom University, and also to officially commence this event. Let's welcome Dr. Zeki Abdurrahman Baizal.
Okay, thank you very much. The distinguished keynote speakers, Prof. Haryati S. Gunawi from University of Chicago, Dr. David Taniar from Monash University, Junedi Sai from Microsoft Indonesia, Dr. Saleh Ayubi, Chief Digital Healthcare Officer at Bio Farma Indonesia, also the honorable all participants of conference and the committee of 9th ICoICT 2021. Assalamualaikum warahmatullahi wabarakatuh. Good morning to you all. It is my great pleasure to welcome you this morning to the 9th International Conference on Information and Communication Technology, or we call as ICoICT. This ICoICT organized annually by School of Computing, Telkom University, which collaborated with Multimedia University, Malaysia, and Gadjah Mada University, Yogyakarta, Indonesia. I'd like to thank to all speakers who have been willing to share your knowledge with us in this event. Also, I'd like to thank Multimedia University and also Gadjah Mada University for collaborating well in organizing this ICoICT. Hopefully, our collaboration will continue in the future and of course in a wider area. Also, I'd like to thank the committee. This conference would not be successful without your hard work. Proud of you all. Also, I'd like to thank to all sponsors, IEEE Indonesia sections, IEEE Signal Processing Society chapter, the Indonesian section Computer Society chapter, Telkomsel, Telkom Indonesia, Telkom Sigma, Huawei, Yayasan Pendidikan Telkom, and also Microsoft who support this conference. Alhamdulillah, we can meet this morning at the soft opening of ICoICT 2021. This ICoICT 2021 is the second ICoICT to be held online because we are in a condition that makes it impossible to meet each other offline. Of course, we all hope that this pandemic will end soon so that we can meet offline with colleagues in the next academic events. Of course, the online meeting cannot completely replace the offline meetings. And I feel there are some things missing, but hopefully this will not reduce our enthusiasm in sharing knowledge in this event. The theme of this conference is digital innovation of post-pandemic recovery. I think this theme is relevant with our condition, with our current condition, where we are all in a pandemic condition, especially Indonesia is currently experiencing the second wave of COVID-19. So we are currently struggling to overcome this second wave. However, beside that, we also have to create a lot of innovations so that we can recover and grow again in the post-pandemic. Through this event, we can exchange knowledge, ideas, which will eventually lead to research collaborations to answer all global challenges. Enjoy this conference, stay safe, and keep healthy. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Baizal, for a very welcome speech. And ladies and gentlemen, let's move on to the next agenda. As we promise you all that you will gain valuable knowledge from the prominent speakers, let's move on to the first keynote session. The first keynote session will be presented through recorded material on the title, Why does the cloud stop computing? Lessons from thousands of bug reports, service outages, and also anecdotal evidence presented by Professor Haryadi S. Gunawi from the University of Chicago. And this session will be led by an interactive moderator. Please allow me to read a brief summary of our moderator. Ms. Nikan Cahyani, STM.Com PhD, is a lecturer and also researcher at School of Computing, Telkom University. Ms. Cahyani PhD pursued her Doctor of Philosophy from University of South Australia, and her research area is on digital forensic, security system, computer networks, and operating systems. Currently, she is working in a collaboration with Indonesia Ministry of Communication and Information Technology to conduct technical meeting in digital forensics. So ladies and gentlemen, without further ado, let's welcome Ms. Cahyani, PhD.
Thank you very much, Master of Ceremony. Very good morning, everyone. Welcome to our first keynote speech session. In this session, we will have Professor Haryadi S. Gunadi, PhD, with the speech title, Why Does the Cloud Stop Computing? Lessons from Thousands of Bug Reports, Service Outages, and Anecdotal Evidence. Firstly, let me introduce Professor Haryadi by presenting a brief summary of his background. Professor Haryadi S. Gunadi, PhD, is an associate professor in the Department of Computer Science at the University of Chicago. He's got his PhD in computer science from the University of Wisconsin-Madison in 2009, and he joined a postdoctoral fellow at the University of California, Berkeley from 2010 to 2012. His research area is in cloud computing reliability and new storage technology. Recently, he published 2 papers. The first one is Experiences in Managing the Performance and Reliability of a Large-Scale Genomics Cloud Platform. And the second one is Fractional Overlap Declustered Parity, Evaluating Reliability for Storage Systems. And he also received several awards, namely NSF Career Award, NSF Computing Innovation Fellowship, Google Faculty Research Award, NetApp Faculty Fellowships, and honorable mention for the 2009 ACM Doctoral Dissertation Award. Ladies and gentlemen, after the presentation, we will have a Q&A session about the topic, and we will collect questions from the Q&A chat menu. So please, if you have any question, you can write your question in the Q&A chat menu. Okay, without further delay, please welcome Professor Haryadi.
All right, welcome everyone. Good morning or good evening, I think, depending on where we are. First of all, I would like to thank you, Ibu Wari Maharani, and Sari, for inviting me to give this keynote talk. I'm honored and humbled for this opportunity. All right, so in this particular talk, I'm going to present what we did a couple of years ago, and I think the content is still valid until today. Basically, the title of the talk is Why Does the Cloud Stop Computing? And basically what kind of lessons we get from studying hundreds of service outages. And again, you could enjoy all the memes up there, when the cloud is down, people cannot do anything, effective, then, they just create memes, okay? All right, so again, this is a joint work with a lot of students, Minche, Riza, Agung, Anang, Jeffrey, and Kurnia. All right, let's start. So I guess, often the time we see headlines like this, right? Southwest Airlines computer outage grounds fleet nationwide, and so on. Netflix goes down, Twitter blows up, right? So there's a lot of issues like that, and actually back in 2014, My team also did kind of a large-scale study of more than 3,000 bugs in cloud systems. By cloud systems, I mean Hadoop, HBase, HDFS, Cassandra, Zookeeper, and many other open source systems that are heavily used in cloud computing setup. But those are very low-level study of bugs, right? And then, from the top, we have this news, right? Headline news of all the major outages that we see in real life. So, I mean, there's a big gap of when you read the news, you don't really know what's happening behind these outages. And when you read bugs, sometimes you also don't understand how these bugs will lead to major surface downtimes, right? So the purpose of this study is to kind of connect the dots and so on. Okay? And again, the goal of this presentation is just to give kind of a high-level findings. I don't most often the time I will not touch into low-level technical details, so hopefully everybody can enjoy this. All right, so the nice thing with, I think, cloud services, right? If you use cloud services, basically they provide transparency, especially in the US. Whenever, for example, Amazon service is down, the developers or the operators, basically after that, they usually provide pages and pages of documents explaining the downtime. Well, why is that? Because a downtime costs people, millions, if not billions of dollars, right? Productivity is lost. People cannot continue their work and so on. Even, 5-minute downtime, it is problematic, right? So that's why they need to provide this transparency. And we feel that these documents are basically untapped information, meaning that, people haven't really analyzed and look at what's going on, how can we summarize what's the problem, and so on. Okay, so there are pros and cons with this methodology, right? The pros are you're gonna get detailed root causes. They usually explain the detailed chain of failures, the downtime durations, for example, if it's 2 hours, 4 hours, 1 day. And then definitely it's zero false positive, meaning that if it's reported, then it means it already happened, right? Of course, the negative is incomplete. Sometimes not all reports provide descriptions, and there's also variance of high variance, meaning that sometimes they report it, sometimes they don't. Okay. All right. So we look at major 32 internet services. For example, for chat services, we have WeChat, Skype, WhatsApp. For e-commerce, we have Amazon.com, email, Gmail, Hotmail, Yahoo Mail. Games, online services like PS Network, Xbox Live, platform as a service like Amazon Elastic Block Storage, EC2, relational database systems, right? Microsoft Azure, and also we have software as a service. Again, we use Google Docs, Google Drive, Office 365. Those basically kind of connect to our productivity, right? And then we have a social network, Facebook, Twitter. We also have storage services like Apple iCloud, Box, Dropbox, and of course, kind of an online video service like Netflix and YouTube, right? So we collect all the reports of outages from 2009 to 2015, and we got about 597 outages. 70% of these outages, they do report the downtimes, right? So meaning that they explain how long they are down, and luckily 60% of the case they do report the root causes. Okay, so great information to study. Now let's look at the number of downtime per year. Oh yeah, so again, if you look at this graph, you see the x-axis, you have this label CH1, CH2, CH3, DT1, EC1, and so on. What do they represent? Well, they basically represent this category. So CH means chat service, email is represented by ML, social service SC, and so on. Okay, so basically I just abbreviate them like that. So you could see that in all, on average, right, there are some services that would go down, more than 70 hours per year, and there are some services, I think the good ones, that might only go down 5 hours per year. Okay, so if we plot this right across all the 32 services and plot this into a CDF graph, cumulative distributed function, this is basically what we get. Okay, let's look at the average number, the annual average, right? So again, what it says is that we get 99. That vertical line, which is about 5 hours of downtime per year. That means you are 99.9% up. That's what we usually call 3.9 availability. 5.9 availability means you are always up 99.999% all the time. That's like a golden availability. But usually, as we can see, many services do not even reach 99.9 availability. Right? If we pick the worst year, for example, for every service, how many hours are they down in their worst year, then we get this red line. Okay, and then we could see a vertical line. I believe it's about maybe 88 hours per year of downtime. That's called 99% uptime. Okay, so 2.9 availability, right? So I think in summary, what we could say is that 6% of services do not even reach 99% availability, right? So that's not really good. And then 78% does not reach 99.9% availability. Okay, so it means 78% of the services, they are down more than, there are cases where they are down more than 8.8 hours per year. Okay, in the worst year, we could see that 31% of the services do not even reach 99%. 81% do not reach 99.9%, right? So again, when we say golden availability, which is 5.9 availability, if I'm not wrong, 5.9 means it's you're only down 5 minutes per year. Maybe it's just a dream, right? Our systems is so complex that it's very hard to get 5.9 availability. All right, so now let's look at root causes of what's going on behind these outages, right? And we're gonna sort them by count. So there are a lot of reports, but I think the problems are so complex that sometimes they just could not pinpoint the root causes, or the root causes are too many, that they might just suddenly out of nowhere fix the systems. But we could see a lot of other causes. For example, software upgrade or hardware upgrade. We have networking issue, right? Sometimes they recable their servers, right, or change the network configuration. We have software bugs. We also have, again, configuration issue when they change their software configuration or hardware configuration. When you inadvertently use a bad configuration, you could down the systems. We have load problem, meaning that suddenly, let's say it's Christmas or it's New Year or any other major holidays, sometimes the load suddenly spikes up. They cannot handle that. We have cross means cross systems failure, meaning that there's your service might not be the root cause, but because you depend on other service, your service, that other service, when they go down, you also go down as well. We have power failures, we have security issues, we have human mistakes, storage, server, natural disasters, like thunderstorm or hurricane and so on, or sometimes again a shark bites a cable, right? Or so again, wild pigs in the forest bite the networking cable. Those things do happen. Those could also cause outages. Okay. All right, so we could see at the top three we have upgrades, network, and bugs. Now let's talk about upgrade, right? Basically, what does it mean? Well, sometimes you upgrade your software, right? But before you upgrade your software, the new software has been tested. But when we test the software, we kind of test it offline, right, in a nice environment and everything. But when they start pushing this new code, new version to the real deployment, what happened is that, there's just a complex environment and the new code doesn't behave as expected, right? So, and that's usually happens because there's just a lot of services and layers connected in the cloud that, when you test one thing in isolation, maybe it's fine, but when you deploy it, you know, your code no longer works as expected because the interaction is more complicated out there. Okay, so to really understand and reproduce this problem, you usually need the full ecosystems. Right? So this is very hard, right? And that's why these days, many major services, they do what we call as rolling upgrades. Like Facebook, they do rolling upgrades, right? They don't just upgrade everybody's software, but they maybe push the updates to only 1% of the users and see how the new code behave. Okay, so that's what we call as rolling upgrades. Another thing that I want to mention, human mistakes, which is actually was a big root cause, 10, 15 years ago, is now quite rare, right? And again, that's because, again, complex systems out there are kind of fully automated. So it's not really human that's causing mistakes, but it's more the software that is causing mistakes, right? And that's why we see that upgrade and configuration issue now becomes, the top 5 issues, root causes behind outages. Okay, so the problem is not in the human, but it's now in the automation process. Okay, so even if you configure things properly, but the configuration does not work within the ecosystems, then you get problem. Okay? So now this is actually interesting sometimes, to revisit the results and looking back what we are doing in research, right? If upgrade problem is a number one problem that causes outages and it's so important, do we actually need more research? Well, the answer is of course yes. But back in 2016, right, we go to major systems conferences such as ASPLOS, OSDI, SOSP, DSN, Eurosys, and so on, and we kind of count how many papers doing research in configuration issues and how many papers do research in upgrade issues, and you can see the contrast is quite big here, right? There are more configuration related papers than upgrade papers, right? So that again tells the kind of the gap between reality and the research we do in universities, right? Because in real world you have a full ecosystem that is so complex, while in academia we don't have such full ecosystems, right? We only work with one software, right? It takes you 1 and 2 years even to master a particular systems like Hadoop, Spark, or TensorFlow, and so on, right? And now when we talk about upgrade issues, usually it involves the full ecosystems, not just one particular software, right? So of course this is a challenging problem, so hopefully the community can solve this in the future. Now the other types of root cause is bugs, right? Software bugs. Now we know software is buggy, so the question is why they are not being masked. Masked mean like, yeah, we know software is problematic. Sometimes you have replication and so on, such that one software that is buggy might not affect other systems. Well, the problem is that we see what we call as cascading bugs. Again, kind of the relate to the full ecosystems that I just mentioned. Okay, let me give you one example. Let's pick a DynamoDB storage servers in Amazon. This is back in 2015, right? So we have the storage servers that contains terabytes, petabytes of data. And we have the metadata service. Metadata means, service that stores file information, file name, more like a metadata type of information, not the actual bytes of the data, right? So now what's interesting is that on Sunday morning, that time, the metadata service responses exceeded the retrieval time allowed by the storage server. So meaning that the storage servers is actually waiting, and maybe after 5 seconds it doesn't hear anything from the metadata service because it's so busy, then the storage servers timeouts, right? So what's interesting is that usually when you get this timeout, they kind of go into a self-defensive mode where this one particular storage server gonna remove itself from the membership, okay, so that not to cause a lot of issues. Now the problem is that we could see this single point of failure where there are actually a lot of other storage servers, and of course they also talk to the same metadata service, and when that happened, the entire storage servers basically remove themselves from taking requests. So at that point it was a major downtime, and almost all the storage servers in DynamoDB are not responding to the users, right? So again, imagine, right, this is a database servers. Imagine all the airlines and all companies that use the cloud database where they store their data. It means all that online transactions will be halted, right? Let me give you another example here. Again, the same thing, right? This is Amazon EBS. It's not really a database, but it's more like a block storage servers, right? So they talk to this data collection service. It's not really a major service. It's just like data collection, maybe collecting information. But the data collection service has a failure. And what happened when there's a failure? Usually, the EBS storage servers maybe doing a bunch of retries, right? But maybe because they keep retrying, there's a memory leak, right? What is memory leak? Again, hopefully in your courses, you learn that sometimes you malloc an object and you forget to free that object, right? So that happens. Or again, in Java, you create an instance and you still have, pointers to those instances, and you just, do not free them. And, over time, you get memory leaks. You don't see that maybe in your computers because you most of the time run a small running jobs. But we are talking about services that run, long running jobs, right? Basically, this is 24/7 service. So all the EBS servers run out of memory, and when you run out of memory, basically the servers will crash, okay? So again, that's basically the high-level summary, right? And we could see that for every type of root cause, right, every year between 2009 to 2015, there's always, more than one instance of the problem usually, right? So for example, for upgrade in the second row, we have 7 issues, 7 downtimes because of upgrade in 2009, 4 downtimes in 2010, M stands for more than 10. M in 2011, and finally 7 in 2015, right? So you can see these things kind of keep recurring again and again. Now you might wonder, right? I mean, these are big companies, right? They spend billions and billions of dollars to improve their reliability. Where is the SPOF? SPOF means single point of failure, because we know that more than 10 years ago, major internet services basically say, okay, if we serve billions of users, we need redundancies, meaning that when you store your file in the cloud, your file is replicated across multiple machines. Not just multiple machines, your file is replicated in multiple cities. Not just multiple cities, maybe your file is also replicated in multiple countries, right? So meaning that there should not be single point of failure. And of course, people say, yeah, we did that. So why do outages still happen? Well, it turns out that it's, again, a complex chain of issues. When you have redundancy, your redundancy will be enabled when the failure recovery chain works perfectly. Now, a failure recovery chain requires three things. First, it needs to detect the failure. If it doesn't detect the failure, it wouldn't fail over to the replica, right? So, for example, if if a service in your city is down and it's not detected, it wouldn't fail over to maybe the servers in another data center in another city, right? So first, you need to detect the failure. Second, the failover, the code itself that performs the failover needs to be correct. And then finally, the backup itself needs to be available as well, okay? Well, what we have is imperfect failure recovery chain. The redundancy is still there, but we have incomplete failure detection. We have failover that sometimes fails, and we also have backups that also fail, okay? Right, so let me give you an example. Incomplete error or failure detection, okay? So again, one example is the memory leaks that I just talked about, right? Memory leaks are usually are undetected. You know, memory is becoming full and more full, and suddenly you just crash, okay? We've seen another issue where it's a load spikes of authentication requests. So what happened is that, let's say you have a lot of requests coming in, like, web searches. Those are type of load that maybe the service already anticipates. But there are different type of requests. Again, for example, maybe a lot of people suddenly logging into the service because of a news or something like that. And it means that when you log in, it will execute the authentication protocols, right? And when there's a load spikes, they forget to detect that could also be a problem, okay? Again, unexpected hardware behavior and so on. Now, let's say, look at the next step. Let's say the failure detection is correct. Then we hope that the failover also works, right? But here we also have failover or recovery that fails. For example, we have bad PLC, where basically, I forget what PLC, I think PLC is just a component in a power generators that when a power generator fails, right, they usually have two or maybe more power generators. So when a power generator fails, this PLC component is the one who detects the downtime of the power generator, and then it needs to activate the other one. But this piece, the PLC, actually fails to activate the other one, okay? Another thing, we have network switches, right, all over the place in data centers. Sometimes a network switch could also fail. But when that fails, it means you need to quickly reroute all the traffics to another switches. But the code that do perform the failover also fails, okay? All right. And then we also, DC data center failover fails due to cold cache problems. So meaning that when you have two data centers, okay, if one data center is down, you need to reroute all the traffic to another data center, okay? But we learn about caching in your systems classes, right? When you're working on one particular data center, most of your data is already in the memory, right? So it means accessing your data is very fast in that particular data center. But once that data center fails and we need to fail over to another data center, guess what? All the files that you're working on and so on, and again, we're not talking about just one user, right? There may be, tens of thousands of users are affected. When you fail over to another data center, the memory is still empty, right? They don't have your files. So now, when it goes to this data center, you're gonna get the cold cache problem, which means that, your activity looks very, very slower because it's all cache misses in that data center, okay? And then another one is what we call as recovery or remirroring storm, right? So again, think about these two data centers. One goes down, and then it means all the traffic, right, gonna be rerouted to another data center. This is what we call as storm. It's a storm, right? Suddenly, the next data center here receives, a load spikes from its original customers and the other customers that get rerouted, right? So, you need to think about those things when you start building big services, okay? Now, let's say the failover works, but then we hope that the backups also work, but sometimes the backups also fail, right? So this is the case of what we call as multiple failures. It's very rare, but it still does happen, and that's why many services out there, they don't just have multiple backups, they have triple backups, right, quadruple backups, and so on. So we've seen double failures of the power, network, and storage and server components, or we have diverse failures. For example, on one data center, it is a network problem, and then as it goes to another data center, turns out they see another problem not in the network but in the server side. We have storage failure and a fiber channel that gets cut, and so on. Okay, and of course, again, I've mentioned to you about cascading bugs, which means that even when you have a lot of replicas, a lot of machines that store your file, but if you have cascading bugs, then all of the files, all of the machines will could die at the same time. Okay. All right, so that's basically what we call cause cloud outage study, right? Again, in the paper, we do more and more correlations about the root cause and downtime, and also surface maturity and downtime, meaning that, for example, here on the second figure, if you have a surface that is, more than 10 years old, we assume that it's a mature surface, and we hope that the downtime will be lower, right? But sometimes that's not the case because, as your systems gets bigger and bigger, then it gets more complex, okay? And then, yeah, we do a lot of, root cause and impacts and root cause and fixes, but I wouldn't go deep there. But, if you're interested, look at those systems. Look at the paper. But again, this is what I'm saying here. This is kind of the reality, right? When you want to build a big internet service that serves millions and millions of users, if not billions, right? We cannot just think about, the feature, right? But we need to think about reliability, because when your service is down, of course, there are other competitors, right? Let's think about Uber, Lyft, and, for example, Grab, right? If a country, for example, in US has Uber and Lyft, when Uber app is down because the servers is down, and if it's down, let's say for 10 minutes, then it means during that 10 minutes, Uber will not get any, request coming in. Well, then you lose a lot of money in that 5 minutes, right? But then everybody will go to the Lyft, right? And vice versa. Okay. So again, that's the reality of building big systems. That's basically outage. For the next one, I will be talking about fail slow at scale. Okay. All right, so let's continue on the second half. I will spend about 10 to 15 minutes. So this is basically another work, and by the way, I apologize that in the first half I just realized that my face is covered by the movie recording button, so I make my face bigger here. Okay, so this is I think my biggest collaboration. Basically, we try to collect evidences of hardware performance faults. So the hardware does not die, but they just get slow. In large production systems, this is with a lot of other universities, companies, as well as national laboratories. Okay, Actually, this all started with this anecdote that I got from Facebook engineers. So they told me that there is a 1 GB network card on just one machine that suddenly transmit at 1 kilobit per second. And this slow machine caused a chain reaction upstream in such a way that the entire 100 node cluster began to crawl at a snail's pace. This is an interesting problem, right? So again, the device does not die, it does not stop, it's still working, but it is slow. So this is definitely a cascading impact, right? So this is just one occasion. Turns out that all hardware cannot behave the same way, right? So disk dropped to hundreds of kilobytes per second because of vibration. SSD stalled for a second. Memory cards degraded to 25% speed due to some connection issues. CPUs ran in 50% speed because of maybe heating problem and so on. Okay, so this is by definition what I call as fail slow hardware that is still running and functional but in a degraded mode, and it's significantly slower than its expected performance. And in existing literature, there are many other terms: failed stutter, gray failure, or limping mode. Okay, but in these papers they usually only describe 8 stories per paper, but in our paper we describe up to more than 100 stories. Okay, so again, this is what happened is sometimes people in academia, when I say this, they say, it's not real, it's rare. But people in industry, they see this all the time, right? So let's write a paper together. That's why I gather all these amazing engineers from companies and other universities who deal with large-scale systems to write a paper together. So we have 5 companies that deal with from 100 machines to more than 10,000 machines. We have 4 universities who have some deployment from 300 to over 1,000 machines, and national labs from 1,000 to 10,000 machines. Definitely big deployment. This is a large-scale operational matter, and they see all this problem all the time. Okay. So let's see what we find, right? So first we find varying root causes, right? So we have why our hardware like SSD, disk, networking component, CPU slows down. We could see internal root causes such as device errors or firmware bugs. We also see external root causes such as temperature problem, power, environment configuration, okay? And again, these are the count of the problems that we have seen, and most of them are based on stories, which means that the system itself does not have the detection in place, but it's the operators who finally see the problem. Okay, all right, so let's look at internal problems. We have device wear outs or errors. For example, and now this gets very low level detail, but hopefully you appreciate how our hardware is very complicated. If you have a solid state drives, okay, they could have this phenomenon that we call read disturb or retry, and it causes page reconstruction. So what happens is that if you want to read your data inside the SSD, inside the SSD device, it needs to read those NAND cells at a very particular voltage threshold. Okay, but what happens is that every time you keep reading those data, it is like a cells that store kind of electrons and so on, right? Charges. So the voltage shift. So what that means, if the device try to read your data X with voltage V1, the device itself might say, sorry, I cannot read the data. So the firmware must retry again with another voltage slightly shifted. And if it doesn't work again, it will keep trying, and finally the 4th time it works. Okay, so that's what happened in our SSD sometimes. Now, in our SSDs we also have redundancy. Again, you could go Google RAIN, redundant array of independent NANDs. So basically what happened is you want to read your data, and there could be like an ECC error, right? Again, some of you may know what ECC stands for. Is for error correcting code. So it tries to repair bit flips that happens in your data so you don't read corrupt data. When there's a read ECC error, it reads other redundancy within that stripe, try to reconstruct using XOR of your data, okay? But what happens is that sometimes when you read this yellow reads, you're gonna get read retries because of the voltage shift, okay? So that's what happened. As you can see, you just want to read one particular page, but there's just so many retries, so many fail over here, that eventually it will be successful, but it will be slow, okay? Another thing, maybe it's not the device that is problematic, not the media, but it's the firmware. So for example, some SSD firmware bugs that, typically when you read SSD, it should be done in microseconds, but sometimes it is slow up to millisecond. This is one article in 2014. One article found a firmware bug in I think in Samsung SSD, something like that, where the throughput usually you could read 400 megabyte per second, and it just drops to almost very low, okay? So again, there's just a lot of internal issues with our device, that it's still working, but it's slow, and that's more dangerous actually, because you might not know what's causing the problem, right? Because it's not stopping, it's not dying, so it's still working, but you say, hey, why everything is so slow? Now let's look at external problem, temperature, right? So it is well known, if you have a hot data center, you have network switches. Well, if the switches becomes very hot, then your packet's going to be corrupted. What happened when your packets are corrupted? Hopefully you remember your networking class. Well, if you use TCP, then TCP needs to retransmit the data, right? So heavy TCP retransmissions will make everything look slow. Another example, same thing with SSDs. If the SSDs become too hot, it will have wear outs, it will have a bad voltage, and it will cause more read retries. There's another anecdotal evidence here. This is a nice looking servers, right? But what happened underneath the floor, there's like some kind of a cold air systems, right? So if you look at this, in the upper deck here, all the machines are, everything is good, the temperature is perfect, but down there is like cold, right? They're very, very cold because the floor is so cold. Now it turns out, if you have disk running in this server, the disk will be slow when it's in a cold condition, right? So what happened is that it keeps trying to read and write, but cannot happen, so a lot of retries, right? So again, something like that. Another external cause is called power issues. Let's look at this. This is what happened when you deploy rack systems. You have a lot of machines, and let's say for every 4 machines, you have 2 power supplies. The 2 power supplies can generate 100% power to each of this machine. But when one power supply is down, then it means you lose 50% of the power. Then you are giving only 50% of the power to each of this machine. So what that happen, your CPU will clock down its cycle, and things will look slow. Okay. Another example is, turns out that sometimes you have a very CPU intensive applications running on one of the machines here. This is what we call as power hungry applications. So when that happens, that particular machine will suck in a lot of power from the same supply, and what happened is that the other machines, the neighboring machines, losing power, and they need to throttle their CPU cycles. Okay, so that's again could happen in these power issues. Okay, so again, there are other environment and configuration issues, but let me just skip them. The other thing that we see is that faults convert from one type to another type. For example, fail transient to fail slow. Fail transient means that sometimes you see it, sometimes you don't see it. So let's look at again your memory card. You want to read a particular byte, right, or word from the memory, and your memory could corrupt itself, right, because of cosmic rays and other failures. So there will be some kind of bit flips. When there's bit flips, the memory will not give you incorrect data. Today's memory, they have ECC, error correcting code repair, to try to repair the bit that has been flipped, right? It's okay if it's rare, but turns out that in certain situations, there's just a lot of memory lines that have these ECC issues. So what happened is, it is transient actually, but it's frequent. And because it's frequent, overall, you access your memory and everything becomes slow. We also have fail partial that leads to fail slow behavior. What is fail partial? Fail partial means if you have a device, only partially some of the components of the device is failing. A perfect example is inside SSD. Again, if you have seen SSD books or chapters, you know inside SSD there's just a lot of chips and NAND cells. And you know inside SSDs it cannot overwrite the same place. So it needs to have what we call as garbage collection, where you have the aggregate exposed space, which is let's say 1 terabyte SSD, but the SSD actually has a lot other space, what we call as over provision space, that you do not see, that you cannot really use directly, right? But they use that internally for garbage collection. Now what happens is that not all chips are created equal, right? If you talk with industry, sometimes some of the chips, they are just a little bit lower quality. So some of the chips die faster. When a chip dies, the SSD still wants to say that, hey, I'm still working, right? Because you don't want one chip to say your entire SSD dies. So what happened is the over provision space gets reduced. When the over provision space gets reduced, it means you're going to see more frequent garbage collection. And when there's garbage collection, again, similar concept as in Java, right? Hopefully you have heard Java garbage collection. And when there's garbage collection kicks in, then everything will become slow, because garbage collection moving a lot of data in this SSD, or in the context of Java, it's moving a lot of data in your heap, right? Okay, so again, this is fail partial. This is only one chip that goes down, but it causes side effect like more GCs and slow down the SSDs. Okay. All right, so and then again, another example of fail partial. Again, this is memory chips, right? Memory card, but inside memory card, there may be one memory chips that fail, and it will actually your DRAM will hide these bad addresses. But what happened over time is that you buy X gigabyte of memory, you're happy, but because this problem occurs bit by bit, eventually you have less and less memory. And in your systems class, like OS or architecture class, right? When you have fewer smaller memory size, then it means that you're gonna get more cache misses, right? And cache misses is expensive because you need to go to secondary storage. Okay. All right, now let's look at symptoms. We've seen varying symptoms like permanent slowdown. We also see transient slowdown. Again, as an example, the CPU, I think I get this flip. If the CPU is hot, yeah, then the performance go down. And if it cools down, the performance goes back normal. It gets hot again, it goes down, and so on. Disk is the same thing. Sometimes when there's vibration, the disk performance will go down, and if the vibration fades away, disk performance goes back normal. Okay. Again, we've seen partial slowdowns, just like the memory cut that I've told you. We also have transient stop. So this is again not like a full stop, but sometimes, there's one deployment where they say they have a lot of SSDs, but suddenly the SSDs just disappear from the systems, right? Meaning that the device says that, hey, I'm offline, and then reappeared again, right? So there's like a deep firmware bug that is going on. A host bus adapter, could do recurrent resets and so on. Okay. All right. So finally, cascading natures. This is again fun, right? So we have cascading root causes. For example, imagine you have a lot of fans in your data center, right? Racks and so on. Usually it runs at normal speed, but one of them died. If that's the case, what happened? Well, the other two here needs to run in maximum speed to make sure the temperature stays the same. Turns out if you run the fans in maximum speed, then you get noise and vibration. And guess what? Noise and vibration will cause your disk to perform slower. Okay, so you can see again cascading root causes. Okay. So again, they see, oh, this is a bad disk because the disk is slow, but it's not really the case. In real world, the chain is just so complicated that it goes all the way back to this one fan dying. Okay. All right. So again, we've seen this cascading impacts. Actually, we were happy we could reproduce the problem that they saw in Facebook a long time ago. But basically, again, many of you know like Hadoop MapReduce, right? Where there's a map and reduce, and what happened is that if you inject a slow nick in one of the map nodes, the reducers, they are all reading the same data from the map, but because everybody reading data from the slow map, there is no, the shuffle is slow, and there is no stragglers, right? No stragglers means everybody is slow, so it means like nobody is slower than the other ones. So if there's no stragglers, there is no failover. And what happens is that all these reduced jobs, they become slow. And when they become slow, they lock up all the compute time in these nodes, okay? So that's what happened, and this is actually what we see, when we inject the slow nick failure, usually our cluster could run 170 jobs per hour, but because we see this cascading impact, finally everything goes down to 1 job per hour. Okay. All right. So again, this is rare but deadly. Things are detected sometimes in hours, but sometimes things are so complicated that they're only detected months from where the problems actually happen. Okay. All right. So yeah, that's all basically. I think conclusion, when you run big systems, right? Big internet services, you have a lot of complex features, and so, but at the same time, you're going to see a lot of types of failures, and they are racing with each other. And again, this is kind of old news, but you could always Google this, right? Biggest worst cloud outages of 2020 or 2019, and you're going to see a long list of outages, right? And that's the reality, and I hope, again, this keynote is useful. Hope our studies, again, tell a lot of interesting stories. Okay? All right, that's it. Thank you, and I look forward to answer your questions.
Yes, okay. Thank you very much, Professor Haryadi. What a nice and interesting speech. So now we are in Q&A session. We still have time for about 10 minutes. So we will open for 2 or 3 questions. And in our Q&A box, we already have 2 questions, Prof. Yeah, the first one is from Ms. Siti Karima. The question is, to what extent can container technologies such as Docker or Rocket here, etc., solve the problems that occur in the cloud? And to what extent has this technology been applied by industry?
Yeah, again, I think first of all, I'd like to say thank you again for the invitation, and Ibu Nikan for moderating this session. Yeah, I think the idea of Docker, right? I mean, Docker or virtual machines is you wrap up all your software and into like a nice independent platform where the Docker container can be moved around. But remember, though, what is behind Dockers, right? Behind Dockers is the kind of the Docker platform software service, like Kubernetes and so on, that basically decides where the VM gonna run, and it needs to detect when a VM or or a container has a performance problem, and it needs to move it around, right? The platform, the software as a service itself, like the Kubernetes or OpenStack and so on. If you download, those are like tens of thousands of lines, a very, very complex piece of code. And bugs still happen in those code, right? So you still could get cases where, again, your container, in fact, one of my recent publications working with a large genomic platform, they run virtual machines and so on, but they have like some kind of hardware failure, and so the VM becomes very, very slow, and all the genomic jobs run very slow. Right. So I think in general, what I'm saying, Docker containers, VMs, and so on. I think those things simplify things for users. So you don't need to deal directly with the hardware. You don't even care where your program is running, as long as it runs is good. So now the burden moves to the software providers, right, cloud providers, in making that all of these containers, all of this is running. They are running robustly. They could be migrated, and so as the burden moves to the cloud providers, that's where the code gets complex and to be heavily tested. Again, what I'm saying is that if we look at the cloud in general, I think they get more. We could say they are more reliable, right? But what's interesting is that in this study, we also look at whether more mature providers have less outages, and I think they do, but we still see outages, right? So, and especially these days, cyber attacks and so on, I think security becomes a big issue. Yeah, so yeah, I think the nice thing today is, remember that many things are very like open source. Kubernetes, you could download OpenStack. You could really, again, appreciate the complexity that all these cloud developers need to do, and all those complex software that they need to build.
Okay, thank you very much, Prof. Haryadi. Okay, we will move to the next questions. The question is from Mr. Fasma Arif Yulianto, and the question is, I just read the question. As you mentioned, actually the root cause winner is the unknown. And I think this is, it is found in from 355 cases. Yeah, and then the question is, do we have no enough knowledge and tools to identify what are actually inside the unknown?
Yeah, that's great. So remember that many, in a complex environment, right? There's like what we call as intermittent problem, right? The problem appears, ideas, you try that, and again, sometimes, if bad things happen to our computer, what do? We just reboot the machine, right? And if the problem is gone, sometimes we don't care about the problem, right? And I think that's partly the reality out there. Sometimes if the problem is so complicated, remember that there's a lot of like silos, right? Different software, different engineers, one team, two teams, and so on, right? So even the best operator, they might not be able to pinpoint a problem because the entire stack consists of so many layers, so many software systems interacting with each other, developed by so many different teams, right? So as long as they could isolate the problem, so basically, if you wonder what Facebook, Google, or big company does when there's a problem, rule number one is not to fix the bugs. Rule number one is to isolate the problem so that it doesn't affect a lot of users, right? So after they isolate the problem, they try to, of course, fix the problem and find the root cause, try to reproduce the root cause. And I think in many cases, you're right, they cannot reproduce the root cause. But I think as long as the service could come back alive, I think they're happy, and life goes on. But yeah, I think ideally as developers, one thing that they would like to see is, again, reproducible failure. So reproducibility is actually a big thing, right? So, and it's also become one of emphasis in systems research these days. And actually, if you look at again, maybe side story, if you look at many systems conferences these days, now becoming like the biology department where any findings, any case study needs to be reproducible, right? So not just submitting papers, they're going to ask you to submit the artifact and everything, and to prove that you could really reproduce the graphs. And there will be like a committee to evaluate your artifact. It's not still a requirement today, but we're seeing that where we're going to make sure that again the community could reproduce your results. So.
Yeah. Okay. Thank you, Prof. We still have time, so for all participants that you still have questions, you can type the question in our Q&A box. While waiting for other questions, Prof, so can we say that in fact, mostly the main cause of the outages is internal, for example, related with its architecture itself, and not external, like because of the security attacks? Can we say like that, Prof?
Yeah, I think based on the numbers, I think we could say that. But again, it's just getting stronger and stronger these days, right? So, this is like a mouse and cat game, right? Who's going to worse, the attacker or the defenders? But you're right. I think if we look at problems like 2 decades ago, there's a lot of systems not expecting external problems like natural disaster, or again we again a lot of funny stories from Google, and like sharks eat the cables in the sea and so on, right? Or wild pigs eat the cable in the forest and so on. Right? Those things do happen, but I think because they know that there should not be a single point of failure. That's why your data lives in many servers, right? I think our data might be replicated more than 3 times out there. Whenever you save your email, whenever you save things to Google Drive, they're automatically replicated, right? Such that if a city blacks out, or if a region goes down, you still could access the data, maybe a little bit slowly, but access your data from other servers. Yeah, so I think that really put the consideration in designing the systems, but the challenge is now is today people demand new features and new features, right? So actually there's a saying that you just don't have time to do offline full testing anymore, because as you implement features, they're going to ask you to deploy the features quickly. So maybe some of you already know the term of rolling upgrades. So actually, for example, if Facebook implements a new features in their Facebook wall and so on, they would actually push that features maybe to only 0.1% of the use, just to see whether the features work correctly. And if it works, they go up 1%, they go up 5%, and so on until everybody gets updated. So that's how they do testing, also like mix of offline and online testing.
Yes, okay, thank you, Prof. Haryadi. Okay, ladies and gentlemen, okay, finally we reached the end of this session. Thank you very much for all the sharing from Prof. Haryadi, and also for all the audience for the questions and the participation from you. And I will hand it back to Master of Ceremony.
All right, thank you.
Thank you, Professor Gunawi and Ms. Cahyani, PhD. And now kindly, we would like to invite both of you to have a photo session. Would you please kindly keep the camera on? All right, so we would like to invite the committee to capture this moment within 1, 2, 3. All right. Okay, so that was very beautiful. Thank you to committee, and also thank you, Professor Gunawi, and also Ms. Cahyani, PhD. Ladies and gentlemen, the next agenda is the first tutorial session, which will be presented live by Mr. Junaidi Sai, Technical Specialist at Microsoft, entitled Microsoft Education Transformation Framework for Higher Education. And this tutorial one will be moderated by our communicative moderator, Dr. Kusuma Ayu Laksitawaning from Telkom University. So please allow me to read her curriculum vitae. Dr. Kusuma Ayu Laksitawaning is a lecturer at the Department of Informatics School of Computing, Telkom University. She accomplished her Doctor of Computer Science from Universitas Indonesia, and her research area is on personalized learning and learning analytics. Let's welcome Dr. Laksitawaning.
Thank you, Ms. Yayang, for the kind introduction. Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Okay, first of all, I would like to welcome you to the tutorial session of the ICoICT 2021. In this session, we would like to have a presentation and tutorial titled Microsoft Education Transformation Framework for Higher Education. Okay. Before the presentation begins, allow me to introduce the speaker, Mr. Junaidi Sai.
Hi, good morning.
Good morning, Mr. Junaidi. He accomplished his bachelor degree on computer science, Universitas Pelita Harapan in 2009. He is now a technical specialist at Microsoft. Okay. Without further ado, I would like to welcome our speaker to deliver the presentation.
Okay.
Ladies and gentlemen, please welcome Mr. Junaidi Sai.
Thank you. So let me share my screen, right? Can you guys see my screen now?
Yes, clear.
Okay, good. So hi everyone. Thank you again. Hope you all stay healthy, right? And thank you for the opportunity that gives to me and Microsoft to speak in this spectacular event. I'm very honored that I'm able to attend and share about the innovations technology that can support our transformation in the post-pandemic recovery situations. But first, let me introduce myself again. My name is Junaidi, or you can call me Jun. I'm a technical specialist in Microsoft. I've been working with Microsoft technology, I think, is about 10 years by now, focusing on Microsoft business applications. When we talk about Microsoft product, right, some of you may be familiar with the Office application, like a Word, Excel, PowerPoint, SharePoint, etc. But that is also one of the Microsoft solutions. But the other solution is about business applications. So business application is about a Microsoft integrated service, which provide a customer proposed build applications to help manage the business function, like sales, like customer service, like field service, like finance and operations, and also talent management for HR department. So during the journey, I also working with some of the cloud technology, like Azure SQL database, Azure web application, machine learning, and some cloud technology that help our customer during the digital transformation journey. So in these sessions, we will talk about a transformation framework that Microsoft created, especially for the education industry. And we will talk more detail in the higher education scenario. Okay. So, but before we jump to the detail, let me walk you through the agenda first. We will start with why we need a digital transformation in education sector. Then we continue with showing you what trend and challenges that we found during this pandemic that have impact educations, and how we develop the strategy and solutions that will help
the right technology to respond, recovery, and reimagine the transformation in education sector. And later, at the end, we can have some great discussion about this. So without further ado, allow me to start the presentation with why. So why we need a change and why we should do it now, right? So I like to start by addressing the topic that we cannot avoid, right? The education sector is particularly impacted by COVID-19, with a school and university district switch to remote learning, yeah, in matter of days, and rethinking the administration and operation from every angle. Without a doubt, this time has put a technology in the center in a way it's never been. Of course, technology has been in the school and in the university for before the pandemic, but in this time, it's become essential, right? We cannot teach without it because student and teacher are at home. The technology connect everyone now, right? So with all the changes in our working life, this moment is when we realize that some of the item is inefficient. Like for example, in the cafeteria, managers will wish for an application to help manage the inventory and track the student picking up free meals. The maintenance supervisor will wonder if there an easy way to log detail of the school and campus inventory. And for the teachers, there are endless scenarios that can be simplified and improved with the right applications. So when we talk about changes also, our chairman and CEO, Satya Nadella, shared some number about this digital transformation. In April 2020, we saw more than 200 million Microsoft Teams meeting participant in a single day, generating more than 4.1 billion meeting minutes and have 75 million daily active users. As Satya put it, we've seen 2 years, worth of digital transformation in 2 months, from remote teamwork and learning to sales and customer service to critical infrastructure and security. And we as Microsoft, we are working alongside, the customer every day to help them adapt and stay open to the business in the world of remote everything. And as we navigate to respond, recovery, and reimagine phases, we all have a collective opportunity and responsibility to define what come next. We know it won't be a business as usual, right? We will need to know what should we rebuild, what should we reimagine, and what should be left behind. When we're moving from the response into the recovery phase, there are three areas of consideration that become important in education's industry. Now everything is become remote learning. The campus experience is become different now. Campus continuity, cybersecurity, academic research become the more important topic now. In little later in this presentation, I will introduce you a framework that we can use, to guide us in the conversation as you plan your recovery and beyond. But before that, let's talk about what's trend that driving changes in education globally. What challenges are impacting the educations and what outcomes that important to you and your organizations? So during this pandemic situation, we see a lot of trends has impact our education sector. They face unprecedented set of challenges. Don't get me wrong; these challenges did not occur as the result of pandemic, but these are long-standing challenges. What has changed is the level of impact, the level of visibility, and the level of disruptions. When we talk about involving the student and faculty expectations, the pandemic has changed how the student and faculty view their campus experience. Responding to the pandemic with a social distancing, contact tracing, remote learning, and other related responses has increased focus on the college and university experience its entirety. And when we talk about remote everything, COVID-19 has brought to the forefront issue of the campus continuity and its relation to institutional risk. Student, faculty, researcher, administration need ability to do their work whether they are fully on campus, fully online, or some mode in between. And when come to remote everything, as you know, there is an unprecedented visibility institution in how they can handle the operation of their campus and increase how they need to make sure about the cybersecurity risk, about the security breaches, about the data privacy. They need to make sure everything, okay? And the question is how we can respond to those challenges and transform using the right innovation technology with the right strategy and solutions. So we have been working with many educational institutions, and we have the research evidence and experience in country all over the world to understand how to achieve the ambitious change without making the most common mistakes. With all of the experience, let me introduce you to the framework that can give you a business agility and a foundation for accelerating the organization outcome. So our education transformation framework identifies a key area across your institution where the Microsoft solution can enable the transformations. The first area is the student success, the green one, from the recruitment to retention to alumni management. And the second area is about teaching and learning, the purple one, involve, like innovation strategy to remote and hybrid learning so you can maintain the education outcomes no matter where the student and faculty are. And the third one is about secure and connected campus. It's the orange one. Build a secure foundations, like maximizing data, streamlining management and operations. And the basis of secure remote collaboration is essential for academic research during the time of hybrid operations. And the last one, the blue one, is how we can support and facilitate the academic research, to make some new innovations to support your transformation and build a roadmap for digital transformations. So this Microsoft Education Transformation Framework is a guide for education leaders to navigate the complexity of transformation that impacting every aspect in their missions. With this framework, you can gain a strategic and holistic view of educations. And in these sessions, we will talk more detail about two framework, which is the student success and about the teaching and learning. And to support the framework, let me introduce you to our approach and technology innovations. Yeah, okay. Start with the Azure technology. Azure is the cloud technology with including an infrastructure as a service, platform as a service, software as a service, that can bring and use for service such as analytic, such as virtual computing, storage, networking, and much more. The Azure Cloud platform, have more than 200 products you can design to bring your new solution to life, to solve the today challenges and also create the futures. On top of the Azure technology, we start with the Microsoft 365. Microsoft 365 is a solution that includes the Office suite that you may be already familiar, like Outlook, like Word, Excel, PowerPoint, OneDrive. And under the brand, we also offer access to collaboration platform like Microsoft Teams, which is I will explain later more detail. Move to the next technology. It's a Power Platform, which is a low-code, no-code platform where you can build an applications, where you can do the automations without needing to know, like some coding. You don't need to write some coding. You don't need to know or expert in some of the programming language. For example, with Power Apps, you can customize an application's capture. So let me show you this one. With Power Apps, you can customize an apps to capture lecture or establish an interactive dashboard to display an information for your research team. With Power Automate, you can cut down the time you spend in administrative tasks and create a flow automate process like grading, like assessment, like compliance, like communication, and more. And with Power BI, the Power BI is the analytic tools. With Power BI, you can provide the actionable data based on the grade tracking and other student information, allowing you to predict the academic pattern and customize the learning experience. And you also have the capability of virtual agents. So in this virtual agent, you can create a chatbot to answer all the questions that been asking by your student, that been asking by your teacher, asking by your faculty member. So the bot will handle all the question first, and if the bot cannot answer, it can be routing to the real agent or the real persons. And based on this Power Platform, we also have a pre-built solution that can be used out of the box with a specific module, like marketing, where you can do marketing automations, the sales module, where we can utilize for the admissions processes, customer service, where we can use it for the student service and customer insight, where we can unify all the student data from all sources in one page, and we can get a 360-degree view of your students. And we also have a finance in solutions for manage your administration process. And what I explained earlier, with all of these three big platforms, we have some collaboration tools we call Microsoft Teams. So with Microsoft Teams, you can access all the applications in this Power Platform, business application, and also Office products. And we don't stop on this. We also develop a solution specific for educations. We name it like Education Accelerators. So the Education Accelerator is built specifically for educations. The accelerator is including higher education solutions, also the K-12 solutions. So you can create a customized solutions, student engagement, internship, scholarship, and much more. And with this implementation, we also allow the university or school to extend the solution based on their needs and requirement. So for example, university implemented this higher education accelerator. The university can be the extender of the ecosystem by many ways. For example, they can develop their own solution in-house. They can develop with the integrator partner, or they can select a partner, to build on the Microsoft platform who have a ready to deploy solutions. They can tailor to support the business requirement that they have. So that's all about overview of the platform that can support and our framework through the digital transformation for your education sector. And let's take more detail on how the platform that we looked earlier and the first framework, which is the student success. There are some important points when we talk about the student success pillars. It starts with the student recruitment. When we talk about student recruitment, how we can achieve a recruitment, admissions, and enrollment goal through the personalized outreach and engagement. When it comes to the student retentions, how we can retain and advance students toward graduations, a holistic view of the student, and predictive analytics to identify when there is a need for interventions. We also need to ensure the best outcome for the student with a 360-degree view of the student and activity by providing the right service and support at the right time to ensure their completions. When we talk about alumni management, engagement, how we can reach fundraising goals and foster a long life relationship by offering the personalized experience across entire student journey. From the recruitment to the career service, you need to respond more dynamically and collaborative as the student needs to evolve, right? So with this, with the platform, you can achieve a holistic view of each student, engage constituent where they are, enable sophisticated engagement. On the next video, I will show you how the platform is empower the student from the start, from the recruitment until they graduation and become the alumni. I will play the video now.
Higher education institutions are complicated, and increasingly they're looking outside higher education, looking at other companies to understand how they can run more efficiently, how they can adopt best practices. But at the end of the day, there are certain things that are specific to higher education and a number of things that surround the constituent. Data has to reflect the uniqueness that represents students or learners. And that's why we're collaborating with Microsoft, because as we started to look at where we wanted to build our solutions, Microsoft made it clear that they wanted to build an extension within their common data model that is relevant to the higher education industry. Now, campus management is built on Microsoft technology. We extend Microsoft products. We run on Azure. But for us to really present something to the industry that resonates, that's meaningful, and will drive true value, it has to be open. That's just a given in this industry. And Microsoft's willingness to take our input along with other partners and institutions to define and build out a common model is really significant and opens up the entire value proposition of Microsoft to the industry. For campus management, the value of the Dynamics 365 Higher Ed Accelerator is to provide a foundation for our applications. We want to build higher ed specific features and functions and deliver IP. We want to build an ecosystem that's relevant to the higher education industry. And by using the accelerator, it does exactly what its name implies. It enables us to accelerate the innovation. We think it will do the same thing to the industry and institutions out there once they start utilizing it. The combination of the Power Platform, Dynamics 365, and the accelerator is really enabling campus management to bring a next generation set of features and functions to the market that are highly relevant and we think address the modern problems facing institutions today. I personally am tremendously excited about delivering what I think is a next generation intelligent engagement platform that's going to deliver a new kind of value to institutions, a unified platform that's part of their existing infrastructure that will enable them to identify at-risk students and intervene early, will give them new insight into how to run their operations, give them a single unified platform to integrate with their colleagues, with other institutions, to innovate and build their own applications. And at the end of the day, it will enable them to take their operations into the future, fully supported by an equal vision and level of commitment from Microsoft.
So after you're watching the video, right, you can see that we have drive student success by providing an end-to-end solutions. So let's walk through the potential scenario here. So this is a journey that a student will take from the recruitment until they become the alumni. So, for example, take this young man in the first scene. After receiving the personalized recruitment materials, he was convinced to apply to your school or your university. And he and his mom are very excited to find out what he was accepted, right? And let's fast forward to the 6 months into his journey. As he finds his footing in a new school in the university, his professor and advisor are use advanced analytics to check in on his progress, see if he's succeeding or if he needs some help. And then these powerful tools also empower faculty to intervene early to reach out those students at risk of failing. Luckily for us, our student is very good and thriving, right? And then he even taking the advantage of the great campus activity outside his study, and thanks to the university ability to create and distribute the engaging community offering. Even taking the payment, applying for a student loan is easier, as our student can do all this through the university simple student information system. And then our student has finally reached the last year of the college and is beginning to think about what job are available to him. Thankfully, his university provide a job resource directly into the student portal, and our student can find a job through his university service. Okay, and let's fast forward again one more time. Our student is now graduate with an established career, but he has nothing because he has, all he has is the good memories with his time in the university. He's very proud of the school he came from and grateful for the investment they made toward his success. Because of that, he stayed to make a frequent donations and stay engaged through the alumni events. So this is the student life cycle from the start and to the end, and how Microsoft can facilitate that journey. So if we get more detail again about the platform and the scenario, the first thing that I want to highlight is about the dashboard. In this look, and this is the look and feel of the faculty member. No, the recruitment dashboard provides an overview of the potential student you are engaged with. The platform can also track the flow of application into school, including the leads record for every applicant with a status, with a lead score and desired major, access to transcript, test score, and more available in a single, in the single dashboard. Sorry. And the next thing, faculty member can also utilize this student 360-degree view. Every enrolled student has a record with the platform. You can place a direct dials to student using Microsoft Teams, or start an email, or view the home address. The record includes an activity tabs that consolidate all the display interactions within the student, like phone call, like email, like task, like appointment. You also can view notes about the student and relationships to other users, like advisor, like parents and professor. And the record also include, the data, the academic data, such as GPA, like a credit earned, like academic standing, like risk profile, and also can be integrated with your SIS or LMS system. The platform also can integrate easily with your institution enterprise applications to monitor the performance and then send a notification to engage with the student. If previously is a look and feel of the faculty member, now let's talk about the student look and feel. So the student will get access to a hub portal where they can access all their data, includes portfolio, assignment, grades, courses, internship, etc. So the portal can be customized to match the look and feel of your existing institution brand. And all the content is originated from the Dynamics 365 from the backend system. And the search feature in here, it helps the student in the right direction quickly and connect them with the resource that they need. Whether they want to know about the financial aid, a guide for getting started with your learning management system, or something they only want to search for. And the knowledge article here, if you can see here, offer the ability to rate the quality of the article as well, view the counter of the keyword for searching, view the trends of the keyword. You can even embed a video to visualize, explain how to concept, Student can leave comment with a question and also suggestions. And the next thing is about case requests and ticketing. And we will talk about the student support cases. A request can be taken from the student and faculty, employee, parents, alumni, and even a business partner. So the service management dashboard keep track all the incoming requests, giving the statistic about active cases by subject, by owner, by origin. So you can filter by the department, such as I only want to show all the cases from the student with a specific major, or I only want to show all the cases that come from the educator, that come from the financial department. You also can do that. And a single record that it's contain a lot of informations, like the unique ID, when the case is created, what is the detail of the cases, what is the priority of the cases, who the cases is assigned for, about the SLA of the cases, and etc. So, and when we jump to the alumni and donor engagement, their platform also provide you a central database, so you can keep track all the donors and alumni. Each entry has the dedicated profile page with contact informations and all the preference, such as whether they prefer to be contacted by phone or they prefer to contacted by email, and etc. So with all the unified student informations from those different area, really helps the faculty member to support the success, from the admissions until graduation and beyond. Because we know who they are, because we know what their needs, it's very easy to get like a picture, because all your data is unified across different locations in one system. It's also easy to generate a useful insight into to do some automation process. So that's the innovation. I mean, that's the overview of the innovation technology we can use to support the first pillar, which is about the student success. Come to the next pillar. It's about talking about teaching and learnings. So the purpose of this pillar is to helping all the students to achieve a potential experience in teaching and learning, including curriculum, assessment, grading, and etc. Well, when we talk about a student-centered learning, it's about creating a student classroom to build a good conversation between a student and the teachers. When we talk about curriculum and assessment, it's required a new tools to access and customize, the progress of each student. Students often learn trial and error, right? So rather than making the test the outcome, school can create an environment where the assessment is part of the curriculum. When we talk about device and for learning, device for learning is about choosing the device that offers superior value and support for the learning. Powerful device can run a real-world software, preparing the student for life beyond school, and enable a rich 3D learning experience that not available in the simple or web content and applications. And when we talk about learning spaces, it's taking up a digital tools. Teacher and student have to naturally begin to seek out more comfortable, flexible, and connected environment that can support the modern learning curriculum. So in the next video, I will show you how the Microsoft technology can leverage this experience, empower the academic for teaching and learning experience.
We know you work hard to support your students, even when you can't see them face to face. No matter how or where you're teaching, Microsoft Teams has your back with new ways to improve reading fluency and save time in the classroom with reading progress. Engage students with easy-to-access collaboration tools. Check in directly with students and promote social emotional learning using Reflect. Foster a positive classroom culture and recognize moments of growth with praise badges. Quickly share and record PowerPoint content so that students can view and learn at their own pace. Learning happens in so many ways and in so many places. Microsoft Teams helps connect the dots so you can focus on what matters most to you, empowering all of your students to achieve more together.
So that's an overview of how we can use Microsoft Teams, a new place that brings conversations, content, assignment, and apps together in one place. It's proposed built for educations and also customize the way the school and the university can collaborate. So in Microsoft Teams for educations, you can create a collaborative classroom that saves a teacher time and better engage with the student in modern learning. You can also personalize learning by assigning a tailored lesson and providing a transparent feedback. You also can connect the educator in the professional learning and communities to improve the teaching skill and also the student outcomes. Also streamline the staff communications on school with the integrated communications. So we can say that this platform enable you to not only do a video conference like we do it right now, but many things like teaching and learning, like coordination between faculty member, like with staff, with student, and a place for educator to do their research and building their community. And the most important thing is you don't have to replace your current investment. Microsoft solution built on the technology that you already have in place, and the ease management by centralizing your learning in one locations. You can open Zoom and meetings in Teams. You can open the Teams meetings in your learning management system, whether you are using Canvas, whether you are using Blackboard or Moodle or others. In addition, Microsoft solution also work across devices, including Macs, including iPhone, including iOS, Android, and also Chromebooks. So let's take some scenario how we can use Microsoft Teams in educations. So in this scenario, you can create like a breakout room. So when you initiate the online classes in discussion, right, you can create a small group room where the teacher and the student can have more focused discussion, and then you can get back all the group into one room again. So this is the feature you call breakout rooms. So let's, for example, like when you teach, you want to divide the student into 3 groups, you also can do that. So for example, like you have one topic, and then you ask the student, okay, you 3 group, and then each group you can work together and then come back again when the time is up, and you can use these breakout rooms. You also have the capability to schedule, a webinar. You can schedule a meeting with the student, and the student can also easily attend the sessions easily. And when it comes to grading assessment, you can do easily using the Teams. So everyone with the right security have the same visibility with yours. So for example, like I am mathematics teachers, and my colleagues is also algebra teachers. So the algebra teachers and mathematics teacher have, for example, have the same security, so they can see the same grading for the specific student, something like that. And when it comes to improve, the readability of the Teams message, sometimes some students have the difficulty of reading the material that you share. You can turn on these Microsoft immersive readers. This immersive reader is a learning tool that provides a full screen reading experience. So it will read for you from the text on the screens. So with that, I will share some, success story that some of the university has been using the Microsoft technology, to accelerate the transformations. So the first one is the University of New South Wales, UNSW. It's one of the group of 8 coalition of the world leading research intensive Australian university. UNSW has deployed Dynamics 365 to revamp its relationship management information system, streamline the interaction with student, business partner, research partner, and the government. They are working with KPMG Australia, and the university is replacing 17 different CRM systems and data sets with integrated Microsoft Dynamics 365 solutions. And with Dynamics 365 was deployed across 8 faculty for the 400 users in 2017 and 2018, saving this university $250,000 in its, in the marketing and the recruitment budget loans. And also following the first deployment, this university able to turn off the system immediately, which saved $40,000 a year and reduce the time required for each student interactions. Many more system has been turned off since they are using these Microsoft solutions. And in addition, UNSW has also integrated the platform with the Microsoft Office 365 and Flow for scan some document integration. So the university is also exploring how the AI techniques can be applied for the issue of managing student attentions by using the Azure machine learning to identify the risk student, the at-risk student. Another example is about Northumbria University. They service over 38,000 students across 8 campuses. In 2015, Northumbria adopted a university-wide strategy to aim to transform the student experience and bring about a real change in the way in which the university delivered a support service. So they implemented the customer service module in this university. So students just need to ask the questions in the portal, and behind the scene, the Dynamics 365 help you to route them to the right place. Now the student can read article about all available support and complete the registration form on the student portal. So this information then route to the Dynamics 365, and when the data is scanned, the keyword is scanned, it will route to the right person and give you the right content to read. So that's I think all from me and Microsoft and about the education transformation framework, and hope we can get some insight about these informations. And if you want to know more about the framework, you can also visit the ICoICT ETF HE, that one for higher education, and you can also visit from there. You can also navigate to the K-12, also the other sector of the educations. So with that, I will end my presentations, and thank you.
Okay, thank you for the informative and interesting presentation, Pak Jun. May I call you Pak Jun? Okay.
Yeah.
Now, we come to the Q&A session. We already have one question here. It is from Mr. Dana Sulistyo Kusumo. Hi, June.
Yeah.
Can we custom the platform so that we can develop our own solution for different clients or users? What API or services offered by the platform that we can use to for our custom solution?
Okay, that's a good question. Maybe let me share again my screen, and we'll explain from there. So in here, if you can see, we got a lot of product, but you don't need to worry about all of this icon. Actually, you can custom using this Power Platform. So this Power Platform enable you to customize the application. So we got the platform here. So we got out of the box feature, like like a sales feature, like a marketing feature. But on top of that, if you want to customize the platform, it's very available. You can do whatever the business requirement you want to do. You can do it with the Power Platform. It's very easy. It's like a drag and drop. You only need to do some business requirement, and then from there you can define which feature that which feature that doesn't have in this current system, and then you can develop easily using the language itself is the C#. You can customize using the C#. You can customize using the JavaScript. So there are two customization here: the front end customization and the back end customizations. The back end customization are using C#, like plugin, like workflow, the programming language is C#, and the front customization, which is the front end, the web apps, is using the JavaScript to do the customizations. And for the API, we support API. So for example, you want to integrate with your current system, you can also do that using the REST API, using the SOAP, using the OAuth, then and whatever API you have, we have the support. We can support the the technology. And if you don't find like in here, you can see Azure technology. In the Azure technology, you have so many functions, so many like services that you can use to do the collaboration with other systems, and you can also customize the function there and to help the business requirement. Yeah.
Okay, thank you for the answer. We have, Pak Dana say thank you so much for the answer. Okay, thank you as well, Pak Dana. Okay, we have another question here from Pak Fasma Arif Yulianto. Okay, talking about what high tech can do to improve our education system is always an interesting issue. Okay. For some of the learners with abundant resource, it is a gift. Unfortunately, for them who have limited computing powers, internet access, and technology literacy, it is like a thunderstorm darkening their days. Okay. Is there any solution which satisfy both of them? Thank you. Have a great day. Okay, what is your opinion about this, Pak Jun?
Okay, I know with the technology, the internet connection has been the problem. Like, so our solution is we not only can deploy in the cloud technology, but we also support the on-premise technology and also the edge technology, and we can also do the hybrids. So for the some of the area that you see, like lack of the technology, lack of the internet connection, we can deploy on-premise solutions. But for the area that have the the good internet connection, have the good technology that can support that area, we can do the cloud. We can do the cloud implementation. So we can do combine between the on-premise and cloud deployment. So we can support the both area. That's my questions about like supporting the area that doesn't have some the infrastructure, that doesn't have the good infrastructure to do these cloud solutions.
Okay, thank you. Because it is so frustrating sometimes for both of learners and teachers if we have some technical issue like that. Okay. Since we still have much time, and I guess the questions is already answered. So can you give us some tutorial or demo of the platform?
Okay,
Maybe.
sure. I can demo a platform for you. Okay, if you can see my screen now. So everything start from the Office 365. If you can see here, I got every application in here, like, like OneNote, like Office, you already know Office, right? Outlook, Word, Expert, PowerPoint, SharePoint, and then we for the platform, we also have the Power Apps, Power Automate, and Power BI that I explained before. And if you go to the Power Apps, in here, you can create a lot of applications. So for example, in these higher educations, okay, in this platform, if you can see, this is the accelerator that I show you today in these sessions, the higher education accelerator. So this accelerator is give you the pre-built solution that you can use out of the box when you install it. So it gives you some of the feature like courses, account, contact, dashboard. Let me show you the dashboard. So in here, you can see about the advisor dashboard. So the advisor dashboard can see all the student GPA, all the performing student, all the appointment, right? And also when you come to the faculty or student dashboard informations, you can see how many students have registered some event or have complete the event. And then another example like how many students has participated in the some of the extracurricular, and also the the academics education level, how many bachelor, how many doctorate, how many specialists and others. And as you know, this dashboard can be configured by the security role. So for example, like I am a faculty member, so I only can see the faculty dashboard. But for example, like I am the the dean, and I only can see some of the student informations. I'm an advisor, I can only see the advisor dashboard. So in here you can configure the security. Also the menu here. Each user can only see some of the menu that they have given the security. So let me take some example about the student 360, right? So in here, that I showed you before, the student 360. So in here, you can see in the left panel, you can see all the contact information, like address, like a national, other, demographic information like citizen, like country of birth. And then when you go to the second tab, you can see all the activity that has been taken by this internship. So like the area of study, the area of interest. And when you come to the timeline in here, you can see all the the interaction between the student and also the faculty. For example, like he has been invited to the some event. He has some appointment with some advisor or some teacher. He have a task that need to complete. And it's very easy. You can create any activity that related to the student. And when there's also information about the academic period, about the course history, in here you can see the internship is taking some courses like auditing, like business writing, like calculus 101, and they also show you the registration status, like is it complete, is it in progress, or is it not yet started, something like that. And then when it comes to test score, you can see, all the score, all the grade are integrated in the system, and you can see the test type, the test date, and the test score value, and etc. Additional detail is only can have this an internship. When the student want to do the internship, they also can apply internship from the portal, and then the data it will show in here, and it can be processed to the next steps. About the scholarships, we also get a feature to do a scholarship here, like when they apply the scholarship, like submission date, the over date, the qualification description, and etc. And if you can see here on the top, this called the business process flow. So this business process flow is guiding you to do the next step in the process of the every process. Like you got the process for admission, right? You've got a process for apply a scholarship. You've got a process for like maybe apply a job. So this business process can guide you. For example, like when I at this under review stages, I need to complete some stages. For example, like I need to submit some document, I need to submit some proof. Then after I submit those document, I can go to the offering pending. So this is very very important and very useful to guide the faculty member to do their jobs. And then another things is in here you can see all the like courses. You can put some courses in here. So for example, like here you can do some customization here. Actually, for example, like when I think some of the question is how you can customize this, right? It's very easy, but let me show you how you can customize this form easily. So you just need to go to the Power Platform here, and then you go to here, and then you can edit here. Sorry. Let me show you how you can customize this. Sometimes it takes time. I just do it from here. So if you want to create an apps, right, or you customize an app, it's very easy. So for example, like in here, I can say that sample apps. Okay, and then done. And here you can define the sitemap, which is the menu. So for example, like here you want to add some menu, which is some table, like account. Okay, and then you want to add some group area gains. So for example, in here you want to add some entity here, add a group sub area. For example, the sub area is so in here you can see here it's all about the table that are already in the system. So you got a contact, you got a course, you got other data that you can use. So for example, here just courses, and then you can save, and then you need to publish it. and then it will show you the application here. See the sample apps that we just created. And if we click here and then we go to the applications, you see the sitemap that we just added is listed in here. So you can do like create a new application directly from the application design here. You can add some some table. You can create a new table. You can create a new entity. You can create a new form from here. So to create a new entity is very easy. So like in here, you can create from the data. There's a table here. It's like you create a new table in the SQL. And here you just need to create a new table. And then, for example, here sample table. And then you can just create here. And then if you can see here, it will automatically add some column, some informations in this table automatically, like created by, created on, modified by, modified on. This is automatically added when you create a new table, and then you can create another table, which is, for example, like GPA, for example, yeah. And then you can define the type of the field, like like this field is for whole number, this field is duration, is time zone. You can define it, okay. And then from here you can also create a form. You can add a new form here, the main form. You need to save the table first. And then in here you can add a new form, like main form. And from here, you just need to drag and drop. So for example, like in the general, you can customize name. You can add the owner in here. You will also in the footer, you can add some field using drag and drop. So like, for example, like I want to add a created by. You can just drag and drop, modified by. And if I want, I need, like a new field, you can also click a new table column. So for example, I need, some field, customized field. So for example, like gender, like gender, I can select it's like option sets, very option set. So you can look up to the table. Yeah, it's simple. You can look up to the table, and for example, like I have the gender table here, so I just need to add a new column here, and then when I creating this column, I just need to drag and drop this one. This is the new field. Okay, so when I finish this, I can just save it and publish it. Then you have a new in the new form, the new applications. So something like that. You can easily customize this. Another things I want to show you is about the Microsoft Teams, how we can easily using Microsoft Teams in educations, right? Let me switch to Microsoft Teams. In here, you can see there is Microsoft Teams here. If I click this Microsoft Teams, so I need to sign in first. Okay, if you can see here, the themes allow you to navigate or create a group of course like physical science, another things like just quickness, health research, the engineering, the algebra, and when you click the themes, it will navigate to this group. And here you can see all the conversation about the study, about the homework, about another things. And when you come to here in the top, you can see all the class notebook. The class notebook allow the student to take some notes. So the teachers can see all the notes, all the student notes, but the student can only see their notes. It has been, you can do that by the security rule. So for here, you can just take some notes. If you are using pencil, you can just write the notes using pencil, the stylus. Also, you got the assignments. You can do the assignment. You can create a quiz and distribute the quiz to the student. You can also, for example, like you can see how many assignment has been returned, and then you can see like Fredrickson and Rocky has returned the assignment. You can also do feedback, and you can see all the information here. And for the gradings, you can, yeah.
Sorry for interrupting, but some audience, including me, cannot see the screen clearly.
Oh, really?
I don't know why. Is it because it's too fast, or
what screen that you see now?
no? Yeah, the list of the students, maybe, yeah. But we can read. We cannot read the name.
Oh, you cannot
just
read
guessing.
The name.
Is it?
Oh, I see. Maybe the internet connection.
Oh, okay, yeah. Maybe the internet connection in your site, or
yeah, I think in my
our site. Okay.
Site, I think.
Sorry for the audience who.
Yeah, I'm sorry for the audience. So, yeah, I hope you can, see the screen. I'm at a screen, that's showing you the student list, and then about the assignment, about the the scoring that the teacher gives to the students. So something like this. Yeah. So this is an overview of the platform. And actually, you can create an application in the Teams. So using these Teams, you can search for Power Apps. You can just add the Power Apps in the Teams. Just click the Power Apps in the Teams. And then you can create an application, start from within the Teams. So for example, let me skip this one. It also provides you with, the templates you can use directly, or you can just start now, start from the scratch. And then, for example, I want to create an application for the algebra themes. I can do it. I think some security issue, but you actually can do, you can create an application direct in the Teams with the same way you are creating the application on the, the Power Apps, this one. So it's the same way you create this application in the Teams also. So that's an overview of the applications. Hope it helps. I'm very sorry for some of the audience that cannot see the query of the applications, but yeah.
Okay, thanks for the demo. So we have another question here from Pak Firman. Is it possible for augmented or virtual reality to be used as an education media? I guess the question is about integrating or embedding the augmented virtual reality to the existing platform. As we know, there are several virtual or augmented reality already released.
Yes.
What is your opinion about this?
Yes, it's very possible to use the augmented reality for the educations. And you can also use Microsoft HoloLens when you're teaching. I can share you some link later in this chat how we can use the HoloLens for educations, how we can use the mixed reality, the augmented reality to do the teachings and integrate it directly to the this platform.
Okay. So is there any other question, audience, from the audience? No, I guess it's all answer. So, I'm interested to ask you. We are applying the outcome-based education. So, are the Microsoft open for customization or modification to align with our educational strategies?
Yes, we are very open. So just bring your business scenario, just bring your use case study, and then we will work alongside with you, and we will do the assessment, do the requirement, and then we will suggest you which strategy, which solution that is best for your business cases. Yeah.
Okay. Also integrating with our existing information system here, yeah.
Correct. Okay. Because you don't need to replace everything. You just need to assess which system that you are already running on and which is already established, already stable, and then we just need to replace some of the component that you are like some component that you are that not suitable. Yeah.
Okay. Okay. So am I correct if I say that the MS Teams is the LMS of Microsoft?
Yeah, you can say that Microsoft Teams are the learning management system from Microsoft, but Microsoft Teams doesn't limit integration with other other LMS. You can use Moodle integrate with Microsoft Teams. You can use also Zoom, integrate with Microsoft Teams.
Okay, so are Microsoft open for research collaboration, for example, for personalized learning? Yeah, because we in Telkom University have a research lab, technology enhanced learning center. Yeah, they do a lot of research on